numbers. Why this distinction of whole, tibuok, whole numbers? Because there are fractions, okay, which are also numbers. Okay? There are decimals, which are also numbers. Okay? So, there are sets of whole numbers. Integers. What are integers? Is there such a number as a negative, say, 1 or negative 2 or negative 3 in the real world? Is there a person counted by a negative 1? Diba? How can you say, we have a population of negative 1,000? What? Okay? But why are we talking about, what is this thing called negative numbers? So they are called integers. Either real or no. Yes, they are. Because they're just part of the language of math. Okay? Ayaw ug libuga. Don't be confused. Ayaw ug libuga kung tinuod ba na ang negative. They are real. You just need to understand or accept the language of math. Okay? Integers. Rational numbers. What are these rational numbers? You have met them all before and we will meet them in the days to come. Okay? Irrational numbers, okay? Real numbers and complex numbers. They are all sets. They are defined collection of distinct objects. Okay? Clear? Okay. Next is the characteristics of sets. Okay? Sets are first finite or countable or maihap. Okay? Previously, a set of 5 fingers. Okay? It's finite. Why sobra, why kulang? There are 5 fingers in a hand, in a normal hand. Okay? Now, a normal hand, because before I met a person who had 6 fingers. There was an extension on his thumb. Okay? So he was an exception. But in terms of sets, in terms of countable, if there is a set, no, our example here is the number of barangays in Davao City. It's how many? Let's say 50. If it's 50, then it's not more than 50 or less. It's fixed or countable. It's finite. Okay. So next is infinite set. What are infinite sets? Okay. Counting of elements that has no end. Walay katapusan. So what is an example? No? What is a real example of an uncountable set of objects? Anybody would like to guess? Okay. The stars. How many are there stars in the sky? How many? Anybody? How many stars are there in the sky?
Dili maihap, sir.
Uncountable. Yes. No? So there are things that are uncountable. So it's called infinite. Walay katapusan. What else? How many drops of raindrops? Raindrops. How many raindrops are there when it rains? Ambot. Dili may have.
Not
Okay?
accountable, sir.
Not countable.
Yes.
Okay? Then 3, there's a universal set. Okay? So a universal set is the set of elements of all elements that are considered. So the example here is if set A has the numbers 1, 2, 3 and set B has the numbers 3, 4, and 5, the universal is sort of the total. Okay? The universal set is 1, 2, 3, 4, 5. Gipondo. They considered or they counted all both in set A and set B. So that's universal set. Okay. Then the fourth set is the empty or the null set. Okay. Represented by the circle where inside there's a slash. Okay. That is a Greek letter for called phi. PHI. Okay? So that set contains no element or Y sulod. Okay? What is an example of an empty set? A set that has zero count. Okay? Is there a car with car no? A vehicle, a car with two wheels? Nanay duha ka linggit? Anybody? A car with two wheels.
Wala, sir.
Wala, of course, because car is defined as having four wheels.
Yes, sir.
Okay? So that cars with two wheels is zero. It's an empty set. Okay? So that's that. So then there's a unit set. Okay? It's a set that whatever happens, there's only one element. Okay? Uh, uh, what's a simple example of a set that has only one element? Okay? The uh, the person in the name of Genevieve Sarosos. There's only set of one. Ikaw lang isa. Okay? So do we have a better sense of the set now?
Yes, sir.
Okay, there's somebody asked, okay, may I interrupt? So Miss Dimpas, yes? You wanted to interrupt me, Miss Dimpas? Anything? Okay, just ask directly. Okay, come back. Okay, so that's the unit set. Okay, now next is the equal set.
Excuse me, sir.
Yes, you are.
Sir, this is Crystal Jane Dimpas po.
Okay, go ahead. What's your
Um,
question?
can I excuse myself, sir, right now? Because I'm having, I mean, mag-overtime kami sa work.
Can you come back?
No, sir. Mag-out kami ng 10 p.m. later.
Yeah, because I need to take your attendance. So I'll take a screenshot of our attendance. Okay. So everybody,
Okay, sir.
you sit still, you smile, and I will take two screenshots. Okay, and I will tell you. Okay, screenshot number one. Okay, then screenshot number two. Okay, that's for our attendance. Okay, Miss Dimpa, so you will be responsible for yourself. You have to study. Okay, no problem. Okay, where were we? What were we talking about? The next set is the equal set. Okay, the equal set is one set that has the same elements as another. So our example here is set A, which has the letters HOPE, and set B, which is the EAOH. So even though the letters are jumbled, but inside are four digits and they are the same exact uh, alphabet. So they are equal, pareho. Okay? Which is not the same as number 7, which is the equivalent set. Equivalent set is defined as one set that has the same number of elements as another, but not the same digits itself. So the example, set A, 1, 2, 3, 4, and set B, A, B, C, D. So they are equivalent because there are four digits inside, but they are not equal. Okay? Are we clear about the distinction? Okay? So, starting today, tomorrow, when you think about trying to understand better the language of math, you apply what you have learned, no? Equivalent, equal, no, etc. Okay? So, number 8, no? Types of sets. The joint sets. What are joint sets? Okay? Sets that have common elements. Our example is set A, which has the numbers 1, 2, and 3, and set B, which is the numbers 3, 4, and 5. So they are joint because one digit is common in both sets, which is the number 3. Okay? That is called common sets. Now, in actual sense, what will be a good example? Let's say uh, what is an actual example? Set A, which is composed of members of your family. Okay, so you, siblings plus parents, that's set A. And set B, members of your mathematics class. Okay, they are joined because what is common in both sets? You, ikaw. So you can call them joint sets. Correct? Okay. Now, going down to number 9, disjoint sets. Okay, they are just sets that has no common elements, nothing common. So, one example, your group of family, your family is a set. Then the number of cars running along your barangay, okay, they both have no connection. Okay, so they are disjoint sets. Okay, so those are the characteristics of sets. Okay, so you have to try to go back to them and understand them more, so that at some point you will be able to understand the world better and express yourself better and get rich, right? To get rich. Okay, moving on. Okay, Angelo, Manalili, you just entered, no? Everybody remind me to take attendance at the end of the class, okay? Because we are, when we took the screenshot, there were 30, now we are 33. Remind me. Okay, moving on. Subset, okay? A subset is a term wherein there is a smaller set within a set or a bigger set, okay? Subsets can be identified and classified. Okay? So my example here, so that you can better understand, no, how it is applied in the real world. The barangay, your barangay is maybe has a population of 10,000 people. So that's the big set. The subsets are, okay, smaller groups based on age. Okay, kids who are 1 to 20 years old, and maybe 20 to 40, 40 to 60. So those are subsets. Maybe uh, the ages 0 to 20 is say 5,000 people. Okay? So now it becomes easier to express that there are 5,000 under 20 age people in your barangay of with a total population of 10,000. Okay? Subsets, part of a bigger set. Okay? So those subsets have also their distinct uh, personality, right? Now, below is what's called a Venn diagram. It's a tool, no, on how you can understand and how you can express, no, the bigger set, the joint sets, the unions of set, etc. Okay, so in order to simplify this Venn diagram, there's 3 little circles. Okay, football with the number 10, volleyball with the number 22, and basketball with the number 12. So probably we can say that uh, football number 10 is the number of students who are who like to play football. 22 students who like to play volleyball, and 12 students who like to play basketball. Now there are common students who like to play, example, football and volleyball. Sorry, football and volleyball, and they are 10 of them. Okay, they are from both the those in the football and in the those found in volleyball. Okay, um, between those who are fond of football and basketball, there's 5, and between those who are fond in playing volleyball and basketball, there are 3. And there are also people who are fond in playing the 3. Okay, there's 5 of them. Now, there's a simple illustration. No? Do we get that? Okay. Walay said no, so I assume you all understand it. Okay. So let us move on to the operation of sets. Okay. Previously in sets there are characteristics. Now there are operations. So operations are similar to the mathematical operations of addition, subtraction, multiplication, and division. But those 4 operations are mostly applied when you talk about uh, numbers. Okay, but here we are talking about sets in general. So uh, uh, sets in general. So uh, the, why the distinction? Okay? In as much as I would want to explain to you why, but very difficult. So just accept it na there's a term about a union of sets. Basta, mauna na. That's it. No? Union of sets, 2 sets that have elements that are found in both sets. Okay? Example, set A of 4 elements, A, B, C, D, and set B of elements B, E, F, G. So when there are when there's a union or when they are unified, it's like they are being added, no? Mura add both. So what happened? No? The universal set of both A and B becomes A, B, C, D, E, F, G. And the letter B does not need to be counted twice because we are just talking about union. We are not talking about addition. Okay? So we see the difference between the operation of union of sets and plain addition. They are both different, right? Okay? So that's union. Next is intersection. The intersection, okay, has the characteristics wherein from both elements they are common to both. Okay? Set A, there's 1, 2, 3, 4. And set B, there's 0, 2, 3, 4, 9. What is common? 2, 3, and 4. And these are called the intersection. So as you see in the Venn diagram above, okay, football 10, volleyball 22, but those who are fun or ang mahilig to play both football and volleyball are just 10. Okay? So that's the intersection. That's how it is used, how you should understand and accept it in the real life. There's an intersection of sets. Okay? So next is the complement of set A. Okay? What is the set A? What is the complement of the set A? We call it the A prime. When you see the A, then the apostrophe above it, okay, the term to use it is the A prime, okay, because it's more difficult to say A apostrophe because apostrophe is part of the spoken language of English, okay? But in math we say it's A prime, okay. A prime is the complement of A, okay, uh, wherein the set of all elements found in the bigger set, which is the universal set, but not in A. Okay. So the example is if the universal or the bigger set has the numbers 1, 2, 3, 4, 5, and the smaller set, which is the set A, is just only 1 and 2. Okay? So what is A prime? A prime is 3, 4, and 5, which will look like the universal set minus the set A. Okay? From the universal set of 1, 2, 3, 4, 5, you took out 1 and 2. So what is left is 3, 4, 5. So, okay. So it's
Sir,
now
yes,
the sorry, question.
sir, unsa ganitong A prime, sir? 3.
Uh 3, 4, and 5. Here in this example, uh in your uh PDF file, are you looking at your PDF file? You can see that below it.
Dili ba mo
Number
download, sir? That's why naga-take note na lang ko sa imong ginay.
Oh boy. Okay. That's why it's you will understand it better if you download it. But anyway, so complement of A is A prime. The term we use is A prime. Okay. In this operation, okay, in this particular example, the universal set or the total has the digits 1, 2, 3, 4, 5. So there are 5 elements inside the universal set. Kumbaga, 5 members inside the universal set, which are the numbers 1, 2, 3, 4, and 5.
Okay na, sir. Dito lang ko medyo na blank.
Okay. So, set A is 1 and 2, and set A prime is what is left, no? So, gibawasan. You took out the digits in the universal set of 1, 2, 3, 4, 5. You took out 1 and 2. That is set A. So, ang nabilin, what is remaining, is the numbers 3, 4, and 5, which we now call A prime. A, then apostrophe sa taas. Okay?
Thank you, sir. Okay na, sir.
Okay. I hope you can download it's better you can better understand it
Yes,
because
sir.
it will be confusing.
Namagod ko sa ospital, sir. Sa akong laptop is na siya sa balay. So, wala na.
Oh, I see. You cannot download a PDF file
No,
in your
sir.
cell phone. Okay. I'm sorry.
Gamay kayong storage.
Okay. I hope you can get out of the hospital soon.
Thank you, sir.
Okay. So that's the third. That was the third set. The third operation regarding sets. No? Complement. Then the fourth operation on sets is is the differences of sets A and B. Okay? The difference usually when we say the difference is when there's a subtraction, but that is not the case. We are not talking about the operations of subtraction, but we are talking about the operations of differences unsay nakalahi, wherein sa A backslash B is the set of elements that is in A but not in B. Okay? Example, set A has 4 elements which are numbers 4, 5, 6, and 7. And set B has the sets 1, 6, 7, 8, and 9. Okay? So what is common in set A and set B are the numbers 6 and 7. Okay? So when we say what's the difference in A backslash B, okay? So unsay what is left, what was taken out that was common. Okay? What was common was the number 6 and 7. So going back to the definition, the set A is composed of 4, 5, 6, and 7. We took out number 6 and 7. So what is remaining from set A is only 4 and 5. Okay? The differences of sets A and B. What is nabilin? So it's similar to the operation of subtraction. But reiterating, let us not uh, confuse, okay, the operation of differences and subtraction. You have to understand the basis of your problem or your situation. Example, differences of sets. Okay. Uh, your family of five. There are, of course, two parents. There are two brothers, one sister. Okay. So family of five, two parents, two brothers, one sister. Okay. Then a basketball team. A basketball team in which the two of team of 10, in which the two brothers are members of that team. Team of 10 included members of the members are includes the two brothers. So what is the difference? You took out the counting the two brothers, no? So what is the difference between A and B? What is left is the two parents and one sister. And on the basketball team, only 8 players. Okay? So the term is the differences of sets. Okay? I hope that's a way for you to better understand it. So moving on, the law of sets. The law on sets. Okay? One, there's commutative law. Okay? The order in which is termed the order in which the sets combined does not affect the result. So a simple example I gave earlier to the 5 p.m. class is example. When you multiply 2 times 3 is equal to pila.
Wala may naka-charge.
2 times 3 is hello. 2
6,
times
sir.
3 6. Yes. 3 times 2 is
6 pa din,
6.
sir.
Of course, di ba? So, in commutative law, no? Even if you reverse 2 and 3, unsa bay nauna? 2. Sa sunod nga statement, unsay nauna? 3. You know? Even if you switch it, they are both the same elements, which are 2 and 3, so they will always get the same result. Okay? Pareho ang result. It will not change because 2 and 3 and the operation of multiplication. Okay? So, commutative law, the order, no, unsay na unsay na ulahi, it will not affect the result or the product. But of course, that is just an example. Okay? Commutative law. Balikin na, go back to that and try to understand those words really so that you will not get confused in the future. The commutative. Associative law is like the numbers 1, 2, and 3. Okay? So you want to multiply 1 times 2 times 3. Okay? But sometimes there are operations wherein you want to do 1 and 2 first, then on a later on 3. Okay? So commutative law is the grouping. No? Even if you change the grouping, but they are the same elements, 1, 2, and 3, okay, they will always get the same result. Commutative associative, 1 times 2 times 3, okay, is the same as 1, or sorry, is the same as 2 times 3 times 1. Diba? So that's associative. Even if you change the grouping, the result is the same. Okay? So that's just a simplification. I tried to simplify it, okay? But it will not become less confusing to everybody. Next, identity laws. No? Identity, uh, uh, what's the word for identity? Pagkatao. That's neither here nor there. Pagkatao. Identity law is a set wherein the at the end of the equation, it's the same. Okay? So the union of sets, if there are two sets, no? you let's say you add two elements, two numbers, and the result is the same as one of the elements. So example, 2 plus 0 equals how many? How much? 2 plus 0 is 2.
Opo, sir.
Okay? So when the identity law states that anything you add to 0, you add to 0 will give you the same number. That's the identity law. There's an animal called 0. You use it, you add onto it, nothing is added, or it will come out the same. So that's identity. Now, for intersection of sets, okay, the identity element is the universal set. So what a good example is example 2 plus 3 is equal to 5. Okay, set A is 2, set B is 3. The universal set or the total set is 5. Okay, so the identity law says that everything is set A, which is 2, is always inside 5. Does that make sense? Anything inside set B, which is 3, is always inside 5. Kaya naaman siya, they are inside, or they are in the same set. This is the bigger set, the universal set, the total. Okay? As I said, simplification. I'm trying to make it as simple as we can because since we are trying to get to know the language, uh, it 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 will confuse us. Okay, so that's identity law. Okay. Inverse law. Okay, this involves the inside and the outside of a set. Okay, before earlier we said there's an A and A prime. Okay, then so when A is unionized is united with A prime, okay, it becomes the universal set. So one example is an example will be if the letter A is 5 and the universal set is 10. Okay. So what is A prime? A prime is the universal set, which is 10, minus at A, which is 5. So meaning A prime is 10 minus 5. So it's also 5. A prime. Okay. So that's the inside, okay, of the complement law. So how do we reverse that? When you unite A and A prime, 5, you intersect it with 5, okay? They are both the same. So there's nothing remaining. Okay? So A, inter- A intersecting with A prime becomes 0 or na 0. No? Intersecting, something was reduced. They are the same numbers or wala, tanan. Okay. So try to understand that. I'm sorry to say, no. Uh, I'm trying to make you understand better, right? Now, at this point, it's past 6:50 already. Today, classes started November 8th, and it is now what, the 10th, the day 9. No, 9 hours we are supposed to consume. Okay, you're supposed to be with me for 54 hours. So we only have what, 45 hours or 45 sessions. Okay, we're not talking about math. We're talking about our class already. Now, so we have only 45 hours left to meet for me to teach you uh, what's this, mathematics in the natural in the world. Okay,
Hi
question,
guys.
including
Wala ko naminaw
Saturdays,
sa
do you
Zoom.
want to
Wala ko
meet
naminaw
in
sa Zoom.
Zoom every
Actually,
day
nagdaba
or
ko.
only a few
Wala ko sa
days in a
CR.
week?
Karoon lang po ko. Nilingkod din sa kwarto.
Anybody?
Sa ako, sir, okay lang, sir.
To be honest, takot
Every
din sa
day for
kwarto.
you.
Yes, sir.
The others?
Bago na po ko nasunod dere. Kay bago na po ko naman og laba.
3 days. You are Mr. Bulao.
Yes.
3 days a week, sir.
The others?
3 days a week.
3 days. There's 3 days.
lang, sir.
But the others, the rest,
Every day.
every day. That's 2 votes for every day.
Monday,
Empezao.
Wednesday, or Friday, sir.
Before we choose the days, let's determine, no, if it's acceptable to everybody. 3 days a week, 2 days a week.
FWF, sir.
How many? 3 or 2?
2 days, sir. 2 days.
2 days. Okay. How about the others?
Mag-vote poll yan ata, sir.
Vote Paul. Okay. Okay. So, uh, okay. Later on, as I will end at 7 p.m. You put your vote into GC. You write 3 days a week. Then you write what days of the week. So Monday, Wednesday, Friday, Monday, Tuesday, Thursday, etc. Okay? Deal?
Sir.
Okay,
Sir.
after.
Yes, sir.
You do it after. Okay? Now, since some of you don't want to meet every day, then you will have to do some self-reading. So I will send you the materials to read. Okay? I will send you the materials to read, and then uh, uh, and the quizzes or exercises as we move along, because I want to cover as much of the mathematics that you're supposed to know so that you will get rich. Diba? That's our ultimate objective, to get rich. So we have to understand math. Anyway, at least we understand each other. I want to help you. All right? So going back, you in the group chat, you send your vote. 3 days a week, then what days? Then we will finalize it tomorrow night. We will go back to Zoom. So, clarification, even if it's 3 days or 2 days a week, do you really want to meet on a Friday? Friday night? Okay? So, it's up to you. What else? So, that's it. Anything else of concern?
Nothing, sir.
Nothing more? How about your first quiz? Are there any concerns? Okay. Those with low scores, I of course I do not mean to, you know, to embarrass you, but uh, 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 I just want to. My message there was that you have a chance to increase your score. So it was up to you, right? So it's still up to you. The day has not ended yet. Although I said until 5 p.m., but the day has not ended. Wala pa naman ng adlaw. So you can still do if you want to improve your score. That's the easiest exam for the year or for the term. Diba? Remember that. Anything else? There's only 3 minutes left. Any other questions? Okay. Who else left? Okay. So, okay, I will do another screenshot because previously there were 32, now there's 33. If anybody else was not included in the screenshot, just tell them to send a message to the GC that, sir, I was present, I left at this time. Okay, remind them. You remind any of your classmates who left. So another screenshot, everybody. There will be 2 screenshots. Okay, screenshot number 1, smile. Okay. Screenshot number 2, smile again. Okay, so if there being no other business, so shall we end this session? Good night, everybody.
Good night, sir.
Good night, sir.
Good night, sir. Good night, sir. Thank you.
By the way, thank you for watching.